Cool. All right. I will let you do the rest. Oh. What is this? Does that look okay? Oh, man. Thank you very much, Leaf. I'm super excited to be here. Uh-oh. That's broken. Is this thing still working? Okay. Cool. This is a good group. There's David Bailey. Nice. Another ex-Redspin ghost right there. Nice. Give it up for Redspin. This is the most Redspin people in the same room. Yeah, this is all messed up now. Leaf broke my computer. Bear with me. Oh, man. Sorry about this. I don't know how this happened. Girl. Yeah. You think I've done this before. Okay, let's try this. This looks better already. Okay, we're back. All right, let's start over again. I am Jimmy Mesta. I am here talking about Kubernetes, DevSecOps, DevOps, all those fun things. This is an interesting mix of people, I'm sure. We'll get to know everybody a little bit. So we have 2 hours. I was telling a few folks before, this is my third stop on a road trip. I was in Sunnyvale last week doing this as a 2-day course for a customer. And I just got here from Florida 2 hours ago on a plane, giving this yesterday as a 1-day course. And now this is going to be condensed into 2 hours. So please keep that in mind. These labs are, there's 10 labs. There's some lecture. There's time for Q&A. There's discussion, but we're certainly not going to get through it because it's usually 16 hours, right? Unless we're all just amazing at Kubernetes, right? So I want to thank OWASP Bay Area, not OWASP San Francisco, right? OWASP Bay Area, Leaf, for thinking of me to come out and paying my way. One leg of this crazy journey. I get to go home on Saturday, but I've been involved with OWASP for like 9 years now down in Santa Barbara. So always happy to come and give back. So a little bit about me. Why am I here? Why am I qualified to do this, right? So that's not me. That's my 7-month-old son. I miss him. He's the best. I am now a CTO at Manicode. Whatever that means. I just became that like last week. So go me, but I'm really still self-employed, right? So I do a lot of consulting in the container space, the Kubernetes space, and I do lots of training. So I do a mobile application security boot camp, as well as this DevSecOps Kubernetes Docker training. So these slides have been in front of probably 300 to 400 developers at this point, traveling around. I don't do a lot of conferences because I'm already on the road a lot. I used to help with AppSec California when I lived in California. I don't anymore. And Santa Barbara chapter founder. So I'm very familiar with this scene and how this goes. And you should give all your money to the OWASP chapter here. It's for a good reason, right? And as Leaf mentioned, I've worked at a company called Redspin doing web application security, web app pen testing. But I've also worked on the defensive side of the house at a company called Agilent Technologies, a mobile app company called TrueCar, and Invoca, which Leaf randomly has a shirt on that I don't even own a shirt from them. But I've worked at all those places. And Invoca is a very sophisticated engineering organization for its size, right? And they introduced Kubernetes a few years ago, and I was part of that team that was tasked to help secure our newly found container infrastructure. So that's what sparked my interest in this. So don't hack things, you'll go to jail, we know that. I'm gonna go pretty fast. So if there's something you wanna talk about, we can, but I'm gonna try to jam as much information into everybody's brains as possible. So we're gonna talk about a lot of things, and I want people to get their hands on the keyboard and do the lab. So we're gonna talk about DevOps, really, really high level, just kind of set the stage for the rest of the evening. DevSecOps, if you want to call it that. We're going to talk three slides on infrastructure as code. Then we're going to go into containers, a little bit about Docker security, container security, image security, and then Kubernetes. And then the labs start picking up at that point. There's a section on attacking and defending Kubernetes and managing secrets, logging and monitoring, and then building pipelines in Kubernetes. So if that sounds all good, then I'm going to press forward, right? This talk has been called like 7 different things. I just decided randomly to call it DevSecOps the Kubernetes Way. Is that what I called it? But it's a mashup, right? This is a incarnation of something I've been thinking about for like 2 years, and it came to life as this, and apparently people like it because they pay me to do it. So yeah, let's go. Welcome to DevSecOps. I'm going to be your guide. And there's lots of memes, right? So I just want to get a quick feel, and Leaf has a way better meme game than I do. I'm a dad now, and like I just use the old ones, but he keeps me fresh on the Twitters. So what's everybody do here? I see there's some people, mostly AppSec security folks. Is there any developers? Any? Oh, nice. But you're not security engineers. You're actual developers. You can write code, huh? Good. What else we got? We got QA, sysadmins. No, that's not a title anymore. Who works with containers in a production sense? Okay, DevOps. So your role is DevOps. Okay. Who's touched the Kubernetes cluster? Okay, cool. So we're going to start from, and I think in the description it said this, we're going to start from zero knowledge of Kubernetes, right? We don't need to know anything about Kubernetes. That's what my job is today. So there are labs. This is a 2-hour training course, right? Which a year or 2 ago to me would have sounded like forever, but now I'm stressed out about trying to make sure everybody goes home with something they can bring to their jobs and be interested in, right? So we have a Git repository that I'm going to share in a second. This environment's a little different than my usual corporate speak. So we have beer and pizza and friends and all these things. So we're going to try to press forward quickly and keep chaos at a minimum, right? You don't get a prize if you complete every bonus. That's not for you, but I'll pat you on the back if you complete all the bonuses. If we run into technical difficulties, there will be bugs. There's always been bugs. This is 11 labs and the most markdown I've ever written in my life. There's probably typos, and that's just going to happen. So PRs are welcome. Please do not file GitHub issues arbitrarily. I've had that happen way too much. And yeah, let's talk about stuff, right? This isn't meant to be a lecture because that's no fun. Okay, so we're going to revisit this as well, but just so everyone knows, this is where we can find our labs for tonight. We're gonna play it by ear a little bit. I tried to pick ones I know that we should do and that build on one another, but if we have an interest in things like a service mesh using Istio, or if we have an interest in secrets in Vault, we can do those labs versus other ones, right? So take a look at this, and if you see something that jumps out, let me know, and we can just make sure to cover it, because we're not going to cover all of them. And this is the fun part. I set this up on the plane, so I've spun up 60 Kubernetes clusters from 35,000 feet, which I think is really cool. in GKE, which is Google's managed Kubernetes service. If you would like a cluster to use for tonight, this is where you're going to go to sign up for it. These are going to get destroyed immediately after class, and then whatever it costs is my donation to OWASP Bay Area. Google right now, I'm on their watch list. This is just a thing. I've been spinning these up in bunches of 60 almost like every week now, and I get emails and calls. They're like, what are you doing? Why are you doing this? It is what it is, and I think I'm good. So go check this out. Yes, there are passwords in there. That's how we're going to do this. And usually I print out little pieces of paper, but that felt a little low tech. And if everyone could go here and put your name or email or whatever your handle next to one of the clusters, so we're not stepping on one another, right? There should be plenty to go around. There's 60, and I don't see 60 people here. Everyone got this? If you don't, your neighbor will help you. We're moving on. Okay, we have a situation, right? Who's this guy? This is the situation, right? And this is the only picture I found of him with his shirt on, so I can actually use this in class. So the situation is, what the hell is DevOps? Why are we here? Your title has DevOps in it, right? Tell me what DevOps is. I'm gonna pick on people.
Okay.
So
it's probably an essential organizational capability which allows you to plug in a lot of gaps that has been in the traditional software development cycle, and it brings the teams which have been organizationally separated, both development and operations together, and it fills up the gaps of those processes which could have been automated. So it gives you an end-to-end pipeline where you can see whatever is happening and you get the feedback from them, and then you do a continuous.
love it. Is that how you answered your interview question when they hired you? Yeah, so I heard a couple words there, right? Automation, there's bridging the gap, there's collaboration between development and operations. There's filling in gaps throughout the pipeline, the SDLC. Yes, exactly. That's all DevOps, right? You win the prize because everyone, I have to pry this out of people on a Monday morning, and they come to their job and they say, it's development and operations. And that's their answer all the time, and it's just horrible. So thank you. Great answer. So we're going to talk briefly about DevOps, right? And at least I don't have an answer for you. It's up to everybody what DevOps really means to you and your organization, but at least let's talk about some concepts. So is DevOps bullshit? Maybe, possibly. Are you a certified DevOps? Presented to James Bentley for guessing multiple choice questions reasonably well? Maybe. Is it the Gartner Key DevOps Patterns and Practices pipeline? I hope not. So this is kind of the problem. This is our situation we're in, right? We don't have a lot of science built into what DevOps is. Companies have now decided that they need it, and it sounds cool, and it's on the internet, and people are talking about it. So we're going to hire DevOps people. So we're going to figure out and kind of deconstruct that, and then we're going to go talk about Kubernetes and how that fits in really well into what we're going to define DevOps and DevSecOps. So this is kind of the state of affairs, right? This is really new. Book by Nicole Forsgren, Jez Humble, and Gene Kim. Just came out like a month or two ago. It's called Accelerate. So they put a survey out to hundreds of companies over the course of a year or two, and basically uncovered, they asked them, what is DevOps? How are you doing this, and what does it mean to you? And they found 24 key capabilities that drive improvements in software delivery. So it's science. This is not this hand-wavy thing that we've been talking about with DevOps for the past 5 years. And Gene Kim, I got to spend lots of time with him at Loco Moco Sec. He's like the leader of this stuff, right? He's been doing this for a long time. So real quick, so number one, continuous delivery capabilities, version control, deployment automation, continuous integration, CI/CD, trunk-based development, test automation, test data management, and then my favorite, shift left on security. What's that mean? Who knows what I mean by what's shifting left? Why would we want to do that? It's expensive to go back, right? In the beginning, and back and do the whole cycle all over again. So That you will fail. Your security team will come and tell you to redo all your code or whatever it is. Correct. So shifting left on security, while it does sound like a little buzzwordy, is kind of the point, right? We want to make sure we're involved really, really early in continuous delivery. Architecture capabilities. So loosely coupled architecture. What's that mean? That's Kubernetes, right? That's microservices. That's deconstructing the monolith, if you will. That's making sure that your bits and pieces can scale independently. Teams are working in smaller chunks. Empowerment of teams, customer feedback, value stream, working in small batches. That's been really important to the DevOps movement, right? And DevSecOps. We're taking tiny bite-sized chunks of code and product and feature and shipping that out. And then team experimentation. So lean management, I'm going to go quick through this change approval process. That's boring, monitoring, proactive notification, WIP limits, and then visualizing work. So this is dashboarding and things like that. Cultural capabilities. This is really important stuff. So we want to support learning. That's a big part of DevOps, right? That's why you're here. That's why I get flown out to BFE, Florida to talk to people about this stuff, because they want to do learning and they want to make sure their teams are all working together, right? Job satisfaction. Who's happy at their job? If you're at Segment, you have to raise your hand. Everyone else is like, I'm sure somebody will hire you here. So if you're in security, if you hate your job, go get a new one. Transformational leadership. We have to make sure from the top down that people are sold on this stuff, right? So all that stuff aside, why do we send these surveys out? Why does this matter? Because this actually makes a big difference to the bottom line of our business, right? That's all we care about. Our CEOs could care less about Kubernetes. They don't really care if we're doing DevOps or making this awesome pipeline. They want code to be shipped faster, more reliably, less downtime, and the product to just work, right? So they kind of, the authors of this book, after they sent out these surveys to all these companies, came out with these statistics that are pretty compelling, right? So a high performer is 46 times more frequent code deploys, 440 times faster lead time from commit to deploy, 170 times faster mean time to recover from downtime. That's really important, right? So the high performers, if they do ship something that is a bug or does take down an infrastructure, they can roll back much, much faster. And then 5 times lower change failure rate. So that's all good stuff. That's why you need to go tell your bosses that security needs to be involved in DevOps. We need to actually start doing this thing. I'm not sure if this is still on. Anyways, there we go. So high-performing security teams. High-performing security teams were more likely to incorporate InfoSec into the delivery process. Their personnel provided feedback at every step of the SDLC, from design through demos to helping with test automation. However, they did so in a way that did not slow down the development process. So my last customer I was at, they run unnamed large static code analysis tool that's really, really expensive in their CI/CD pipeline in Jenkins. And every single developer there was like, oh, that tool, I hate that thing. I've actually built Jenkins nodes to just go around it and make my own build process. So the point isn't to slow down velocity. The point is to bring security in, right, and make it go faster. We want to be able to run these scans and do what we do in AppSec in a way that's not going to hinder development. And I'm going really fast, so bear with me. So with that being said, my hopes and dreams for tonight are to at least help you move the needle a little bit to being a high performer, right? We want to apply a little bit of science to what we're doing in DevOps and DevSecOps and all of these acronyms and buzzwords. Common consensus or not, doesn't matter to me, of what DevOps is and what DevSecOps is. Understanding Kubernetes from a technical perspective, right? I think most people sign up for this course because it has the word Kubernetes in it, which is a good thing, and we're gonna do that. But I'm gonna give the like Kubernetes 101 here in a few minutes. That's gonna be where we all start. So if you are a Kubernetes guru already, I apologize. I will pick on you to help me, answer questions and things like that. Deploying software more confidently and exposure to only the best memes, right? I like that I can have fun here and I'm not on the clock at some stuffy company. That's nice. It's much different. Okay, Like 3 slides on DevOps. This is what DevOps is not, right? Do I have to go over this? We all can agree that DevOps is not firing the ops team, having ops deal with it, or just hiring our friend over here, the DevOps unit. That's not necessarily DevOps. So what is DevOps? Or what is it not still? Anti-pattern, throw it over the wall. We all know and love the proverbial wall that we kick our code over to. Operations handles it. This is a fun one that I've lived through twice now, where we've decided, somebody higher up decided that we need to hire the Hitman Rockstar DevOps team, and they need to come, and we're not allowed to talk to development or operations. We have to funnel everything through the DevOps team. So that just creates mass confusion. There are ways to have a DevOps team and have it run effectively, but sometimes just having that as a separate silo adds to the problem. No ops approach. This is operations just doing their thing, and development handles DevOps. I've seen this just about nowhere. The opposite happens all the time, right? That's this one. We've all seen this, right? This is Disaster Girl, who is now like 30 years old. If that makes you feel pretty old. She's like a grown woman. Not good. So what is DevOps? Development and operations collaboration. It's cross-pollination. It's everybody getting in the same room. It's everybody talking about the same thing. It's also could be a fully shared responsibility model. I know there's some Netflix people here, and that's kind of what Netflix is known to be doing, at least from the outside world. I don't work there or work with them, but everybody kind of knows a little bit of everything about the software development, what machines it's running on. You're handling some of the deployment of that and monitoring and all those good things. And then DevOps as a service. So this does work, right? If you have the internal DevOps consulting team, which might be what you're doing, versus a separate silo, that's great. That works pretty well. You can kind of be transient, right? And go from team to team and help everybody do their instrumentation, bring in dashboards, build a pipeline for the different Scrum teams, things like that. That works really well. This works equally as well for security teams, right? Where you have this kind of model where you float around and you're helping everybody write software and deploy software securely. Okay. People, process, tools, and buzzwords. That's what DevOps is. So number one, collaboration. This is moving a little bit beyond just having the DevOps Slack channel. Hopefully it's a little more than that. But it's really actually working together, solving problems together. Cross-training, so that means developers are trained on what Kubernetes is. Developers are taking security training and learning how to hack their own web applications. Leaf was telling me a great story about how they're handling that here at Segment, and that's great. Developers don't want to write shitty code, right? They want to put code out there that is secure and runs in a robust manner. So training on security is paramount. I can swear here, right? Yeah. Sorry. I don't get to do that ever. Feels good.
Get it home, can't swear.
I know, I can't. We have a swear jar. Supporting business agility, that's what we're doing, right? Nobody's business generally is making money off of your Jenkins pipeline, right? So we need to support whatever it is the business wants. Breaking down silos, automation of repetitive tasks. What's a repetitive task in security that we could automate tomorrow? Who knows? Static analysis, dynamic analysis, IP tables. There you go. Asset inventory. Yeah, nobody knows how to do that. Okay, who has a good asset inventory management process right now? You do? How do you manage your assets? It exists. What about you? IBM, yeah, Big Blue's got it figured out, I guess. There are tools coming out, but most people are using spreadsheets, right? And weird configuration management tools. Everything is code. What's everything is code? What's an example of that? Infrastructure is code. The application, Terraform. You check everything into it's version controlled. It's all has a bunch of eyes. You have PRs. You have all that good stuff you had with applications. Now it's for everything. Test, measure, monitor, rinse and repeat, right? We have dashboards, we have all this good stuff. Okay, got this. Okay, we talked about all that, we're gonna skip it. So with that, this all presents some problems for security teams, right? So our windows for running our super heavyweight scans that we all know and love, Zap, Burp, Contrast, all these things that are pretty heavy, that's shrinking a lot. People are deploying every minute. You're not going to be able to do that every time. Continuous delivery scares the hell out of security teams, right? That's just a scary concept where you have zero insight into that artifact that's eventually just going to go to production on its own. We're seeing framework, language, and infrastructure fatigue, right? Well, you're at Netflix, you write code in lots of different languages, right? But everywhere I go now, it's like, well, I want to do something in Golang. I want to write a microservice in this thing and this other thing. So for security people, that's a new skill set we have to learn. We can't do manual analysis quite as easily if we don't understand every language. And then all the frameworks, especially JavaScript frameworks that exist now, make this pretty difficult. We're always outnumbered, we know that. Automated detection of complex issues, that's really hard work. Business logic, sort of flaws and really funky AppSec things that only a human can find, you can't Jenkins your way out of it, right? Third-party code, libraries, APIs, tooling, just scattered everywhere. You know, we're pulling in code from unknown sources, we're pulling in Docker images from horrible places, and we're running them in our production infrastructure. We're mining Bitcoin for people. It's great. So we want to turn this pile where security is picking up the mess of DevOps into this, right? So we want to ride the golden pony off into the sunset and then have compliance deal with the mess. But we have competing forces, right? So we have development, ops, and security doing different things. The business is telling us to go fast, go cheap. They're saying don't ever go down and then don't get hacked. These are very hard goals to accomplish as a team. Skip that. So my definition of DevSecOps is the process of incorporating and enforcing meaningful security controls without slowing down deployment velocity. I think that's really important, and that's the key takeaway of this little section in the beginning. It's really not about making teams go slower. You want to be involved earlier, shifting left, right? So crawl, walk, run, fly. It's a journey. We're all on this journey together. Okay, infrastructure as code. How are we doing? Does everyone have enough beer? I'm gonna need one in a minute. Is your infrastructure self-documenting, version controlled, capable of continuous delivery? Are you doing integration tests on your infrastructure? Is it immutable? What's immutable infrastructure mean? Replace instead of update, right? Yeah, don't touch it. Don't SSH to things and run any sort of commands. So this is how we want to do things. And if we don't have this in our mind early, Kubernetes isn't going to make any sense. You don't SSH to a container running in a pod in a Kubernetes cluster and like do a sudo apt-get update upgrade and like do some weird commands. Like you just don't do that anymore. It's gone. Forget about it. You replace. So this is how we used to do it. We have at v1.0 and at v1.1, and we would just keep piling on the cruft, right? And until a special snowflake appeared that nobody knew how to manage. A company I worked for that shall remain nameless was notorious for this. 12-year uptime on one server. We weren't allowed to access it, and then it just went away one day, and then it was gone. So immutable infrastructure is the destroy and provision, right? That's where we're going. That's Kubernetes, that's containers, that's why we do this. As a security person, I like immutable infrastructures. I have a golden image, right? I have a versioned a library of components I'm pulling from. I have operating systems I've vetted, and I have eyes on that now instead of just deploy what you want, configure it how you want it, and then if something like shell shock comes out, you have to like go to every machine and figure out what package, which version of a certain package you have installed. So it looks like this. It's really simple. Here's our version catalog, Ubuntu, packages, Docker. Here's our code in a base image. So we can run a SHA, like we could hash this and we can say, is everything running this version? Because this SHA-1 hash should match, right? issue comes out, we update the package once, we push it out to our fleet, and we don't have to freak out. We don't have a 3-week engagement to try to do forensics on what box is running certain version of libSSL or something like that. So this is why we like this sort of thing. And this is why containers, as they enter the stage, make a lot of sense. There's DevOps, bro. And grouping and tagging, right? We can slice and dice our infrastructure now. We can start doing QA tag, prod tag. We can say front end, back end, all this stuff. And this is really important in Kubernetes. If you've ever worked in Kubernetes, it's all about labels. That's all. We have to label everything now. So cattle, not pets. We know that. Security wins. We talked about most of that. Okay. 30 minutes in. So I'm going to pull lab 1 up. Lab 1 is not the most exciting lab, but we have to do it. This is just getting familiar with our cluster, right? Not even our cluster yet. So 2 quick notes. I'm graciously giving everybody a 15 gigs of RAM, 4-node Kubernetes cluster to use for the evening. So don't mess with other people's, please. That's not going to be funny, probably. That's just going to be a pain for me. And you're under the manacode.us project domain. And we're going to use Google Cloud Shell. Who's used Google Cloud Shell before? So it's just, all you need is a web browser. So you don't do any of these commands in your terminal. You can, but that's kind of choose your own adventure tonight. We're using Cloud Shell for all the labs because we just gotta get it done, right? So Cloud Shell is built into the browser, and you can interact with your Kubernetes cluster straight from there. It's got Docker installed. It's got all the tools we need for tonight. So if everybody could make sure that they log in. If you are already authenticated to other Google accounts, which you probably are, you could do this in an incognito window. That would be probably better than trying to juggle all the different accounts, personal accounts, what have you. And what we're going to do is pull down the repo into Google Cloud Shell so we can then use the Kubernetes manifests. Okay, go. We have 5 minutes. Did everybody sign up for a... How many people do we have? Oh, I love the random order. Oh, nice. It's a ride-sharing board. So I'll log into one of these as well just to play along. I know I'm going really fast, but I'm happy to talk after, during, on Twitter, whatever you want. I just wanted to get that part of the spiel out of the way. Anybody have 2? Yeah. Let's do OWASP 4. Who's done with lab 1? I always like to ask that to make sure something's not completely broken. So you will have to select the project, right? So I'm going to step through this with you. Step 5, it is, you can find it up in this select project drop down. This guy right here. So what I just did there is you have to be part of the manacode.us domain. So kind of a weird it doesn't drop you into it automatically. Kind of annoying. So if you, once you do that, you're going to see the quickest way to get to your Kubernetes cluster by far is going to be going to Kubernetes Engine. Who knows what Kubernetes Engine is? Okay, I'm going to have you help me help other people for some of the labs, if that's okay. What's your name? David? Okay, cool. We have a resident Kubernetes expert. So this is a managed Kubernetes service, right? This is kind of a newish thing. And we're going to talk about the components in Kubernetes, but this is a shared master sort of thing. So we have 4 actual nodes in the cluster. So when you hit connect, this Cloud Shell button and Google really hates when there's 60 Cloud Shells running on the same project for some reason. So if it goes a little slow, I hope it doesn't tonight. This command right here, you hit enter, this grabs the credentials from your cluster. Don't worry about what's going on in the back end right now. We just need to authenticate to it. And then we run our git clone. So the cool thing about Google Cloud Shell, I think, is this little IDE that's built in. Once you clone that repository into your Cloud Shell, this is just a little VM. It's probably just a Docker container itself. You're going to have a web-based, browser-based IDEs to start messing around with files and reading markdown files and things like that. So once this is set up, just kind of leave it open in a tab because we're going to be using this view quite a bit. I didn't do the git clone yet. Now, there's a shortened link that I had up earlier. One of your neighbors can probably help you. And then you'll find a username and password already provisioned. Did you use that? Oh, okay. Oh, it'll ask you for that, but just skip that. You don't need to start the trial. These are going to get blown away in 1.5 hours. So it's already on an account that's tied to a billing account. So you're good there. Yashvir can help you.
Just like, what's the cluster name? I got the project name.
Oh, go log into, where's your,
Here.
okay. So go up here to this little hamburger and go to Kubernetes Engine.
Oh, yeah, okay, here.
Yeah, you'll
The
see your cluster there. You got to accept these. They're just
Okay, got it.
TOCs. Okay, I'm gonna keep going, and if you're still working, that's okay. Name of the project's up in the top nav bar.
What's the same?
They should be the same.
They should be the same.
Yeah.
It's the same.
Yeah. Okay, I'm going. We all know about containers anyways, so finish this up as I'm going. I do apologize for the speed and intensity, but I think it'll be worth it because this is kind of a hard topic, right? Kubernetes is not a small set of technologies. So containers, we need containers to run Kubernetes. Before we start thinking about an orchestration system, we need to understand what are the components, what are the deployable units that we're going to eventually place into our cluster, right? We have this beautiful, pristine 4-node GKE cluster that we have access to. How are we going to run a microservice on it, or a web app, or an API? So that's with containers, right? That's this guy, that's Steve Ballmer. It's just containers. So the 30-second 30-second VM container overview. So who can tell me the difference between virtual machines and containers? I'm going to have somebody else do it. I know there's people here that are going to be able to answer that. We share a kernel in a container, right? That's where we get our speed and the size of the actual image itself, all that good stuff. This isn't a container, an evening of containers necessarily. We could talk after, but for the most part, we don't replicate guest kernels when we use containers. It looks like that, quite simply, right? And they're packaged up in a nice, pretty bow using Docker, which is a series of command line utilities. So we have process security, process isolation. Kernel namespacing is kind of what enables us to do this, right? This isn't a new concept in Linux at all. It's the PID namespace, network namespace, and mount namespaces. The combination of these is what allows 1 to n containers to run on a single virtual machine, and they don't know about one another technically, right? So it's through kernel namespaces. That's what it looks like. We're spawning off from PID1. We can have another PID1 in a container, and then 35 PID1s later. This is important in Kubernetes because we're running many, many containers on one single node. Control groups ensures each container is provided with its share of memory, CPU, disk, I/O, et cetera, et cetera. Docker wraps all this up into one pretty CLI, one daemon, one API for you to go talk to and create containers, pull containers down from a registry, all that fun stuff, right? This is what it looks like straight from the Docker documentation. But for me, as an AppSec person, there's some scary stuff here, right? Bitcoin miners getting pulled in. That's a thing now. App vulnerabilities. They don't go away with containers. They might be amplified even, right? Sensitive volume mounts. You don't want to give containers the ability to bring in root type access or volume mounts from the host that have passwords or sensitive data. API exposed over HTTP. This is how the client talks to the Docker daemon. We want to make sure that we have TLS in place. We want to make sure that we're not giving out shared certs. We want to have authentication on the API. And I'm going to give all these slides out at the end. So yeah. Or you can take pictures of them. It's probably not as useful, right? Container security benefits. Patching becomes quick, right? We have this notion of our golden image. We could send out a patch if something happens tragic on the internet. If there's a vulnerability that has a logo and its own website, we can just send a patch to our image registry and roll out new containers. It's immutable, beautiful. So short lifespans. So this is really important in Kubernetes, right? We don't do a Docker run on a server and just hope that the container sits there for 9 years running. Like that's not what we're doing here. With immutable infrastructure, this thing is like moving pretty fast, right? I'm sure at Netflix scale, these containers are coming and going in a matter of seconds. Isolation from others and one process per container, ideally. So we don't want to have a container that has 16 processes running, SSH, and all this other crap. You just want to have what your app needs to run, and that's it. No special snowflakes. This is a good article from the folks over at Heroku. You can check it out on your own. You all have the slides. It's all about Docker in Docker, or dined, which is crazy inception of installing Docker in Docker containers, mounting the socket into that Docker container, back to the root file system, and all this crazy stuff on AWS code pipeline. And they were able to actually get into the underlying AWS infrastructure, print out environment variables, et cetera, et cetera. Good stuff. You can break out of them. Yeah, this is Shocker from a few years ago. This is the new drama. Tainted crypto mining containers pulled from Docker Hub. So we're all security people. Do we allow any third-party library to be pulled into our source code at will? Yeah, just go for it. Yeah, so that's not great. So we shouldn't pull operating systems into production from the internet. Do we get why that's bad? Okay, we don't have to go there. So we can look for vulnerabilities in these containers, right? In the images themselves. Encore, local Santa Barbara company, check it out. Claire is really popular. K is an image registry that does a bunch of security scanning for you. Google has this now built into their image registry. Docker registry also will do it if you pay the money. Okay. When you see this little logo down here, that means we're not doing this lab because we don't have time. So this lab, I'll just talk about it for a second. All it is using the Docker, basic Docker commands to build a Docker image of a Golang API. You feel free to go do this on your own whenever you want, right? So I don't think it adds value to Kubernetes tonight, so we're not going to do it. And we don't need it for later labs because ain't nobody got time for that. All right. Okay. So let's talk about Kubernetes. So we talked a little bit about DevOps, DevSecOps, immutable infrastructure, and we talked about containers very quickly, albeit, but we're here. We're at Kubernetes. So this is a shipping ship, shipping ships. And this particular ship, I don't remember what it's called, but it's badass because this whole unit goes way down into the ocean and it'll pick ultra heavy things up and take them around the world. It'll pick up oil riggers and all this stuff. So it's on Wikipedia. You can check it out. So who can tell me what Kubernetes is? Who wants to do my job for me? Yeah, DevOps, bro.
So basically, it's a desired state management tool.
Desired state management tool.
It always would manage your desired state of your application. That's what it was designed for, I guess.
That's fair. Yeah. So the answer was desired state management tool. That's definitely a big piece of Kubernetes, right? We expect 13 of a thing. Kubernetes makes sure there's 13 of that thing, and it has the technologies and the components to watch over those objects to make sure they exist. Yeah, that's one piece. What else does it do? Orchestration. What's that mean?
It's actually really hard to log into 100 Docker instances. Docker run. Deploy that thing somewhere.
Somewhere. You handle it, Kubernetes.
And then I'm going to go contract. 5 web servers. Things in the middle area.
It'll do its best to make sure that happens. Yeah, great. What else is Kubernetes?
Also to make files in your cloud. I want to make sure my unit of scaling is 3 app servers and a data center.
There you go.
Whole pot out at a time.
Yep, cool. So all great answers. Thank you very much. Kubernetes is built to automate deployment, scaling, and orchestration of containers. Great, we talked about that. So we have our container, like you alluded to, going to a bunch of Docker machines on a host and saying Docker run, Docker whatever is definitely not going to work in any sort of scale. So you need an orchestration layer, whether it's as simple as Docker Compose, it's not really an orchestration layer per se, all the way up to Kubernetes and everything in between, right? It's portable, so clusters, and we'll talk about the notion of a cluster in a minute, can be deployed on a set of Raspberry Pis if you want, if you have the time on your hands that weekend. You can run Kubernetes wherever Linux runs, right? You just need VMs or machines, and your laptop can run there. Customizable, so you could pull things out of it, you can customize the code, it's all open source, it's written in Golang, you can do what you want with it, and you can also get yourself in trouble doing that. Scalable, so we have node self-healing and we have container self-healing. So depending on your cloud provider, Kubernetes can scale from, we have 4 nodes here, but I could tell GKE to say, I want a minimum of 2 and a maximum of 50. And based off of the load and certain metrics, it'll actually, on behalf of your cloud, go and spin up new nodes. We get replication out of the box. So we talked about, I want 5 of a thing, 5 containers running on a machine. Kubernetes is going to supervise that operation. Okay, cluster, easiest one. Just a bunch of VMs. Kubernetes is in charge of these VMs. They're not just randomly dropped in there. They're configured by Kubernetes and have lots and lots of packages and components installed, right? So this is a 1 master, 3 node cluster. We're working with a 1 master that's shared and a 4 node cluster tonight. We could have multi-master set up as well. I think the limit for Kubernetes, and don't quote me, is like 5,600 nodes before you have to call Google and get help. And most people aren't hitting a 5,600 node limit unless you're Netflix. Pod. That's how many? 65534. Okay. 65534. Who has that many VMs running in their Kubernetes cluster? Pokemon Go probably did. We saw what happened, right? What's a pod? Who can tell me what a pod is? Over there. Duo man. I forget your name. It's the smallest deployable unit that we're going to talk about tonight. We're kind of going to throw away the notion of just containers, right? Because you don't take one container and run it in Kubernetes, per se. You place it in a pod. It's an abstraction, so it's grouping containers together. And they share the same network and storage. So it looks like this. This is a 3-container pod. These containers are all going to talk over localhost. That's really important as if we get to Istio, service mesh, sidecar stuff. Just know that 1 container is ideal. 13 containers in a pod is not ideal. Like there's a certain unit of scale that you do not want to be just shoving containers in pods because these are going to scale together and they're all going to have the same network interface. So I've seen people try to put like Rails, Redis, MySQL, some sidecar container that does logging, all this stuff. But you have to remember that they're going to live and die together. This is what, as you alluded to, the YAML. So when we talk about Kubernetes, we're literally just doing a bunch of YAML. And whether you love or hate YAML, that's kind of what we're stuck with in Kubernetes. That's okay. This is a pod. This is a 2-container pod. This is, where does this image come from out of the box? Who can tell me? That's Redis, yes. But where is it pulling the image from? Docker Hub. Yeah, that's good to know. So by default, Kubernetes is going to pull from Docker Hub, right? So we have 2 ports, same as our Docker run command, right? How you expose ports out to your local machine, out to the world. We're doing the same thing here with this pod manifest file. But we don't use these in the real world, and I'll show you in a minute why. So we take YAML. The operator then submits that to our master. We have a master running. The master is going to make some decisions and talk to some of the components and schedule that pod to be placed on a node. This is going to go to node 2. Now we have Rails running. We're happy, right? What's wrong with this? Would we use a pod manifest like that? Does anybody know? We wouldn't, because there's nothing watching it. We didn't tell Kubernetes to respin the pod up if that node goes down or reschedule it on something else. So we don't really deploy, we don't really use a manifest with the kind pod in production. It's the equivalent of it like Docker run. We're not getting the benefits of Kubernetes. So we use a thing called deployments, right? They used to be called replica sets a year ago. But now deployment is what we use. We live, we die, we live again, right? That's what we want. We don't want the pod just to go away and not be rescheduled. Deployments are how we tell Kubernetes, go reschedule this thing on node 3 if node 2 is out of service. Ensure end pods are up and running. Yeah, so quite simple. This all looks the same, right? This is exactly from the last manifest, 2 containers, Redis and Rails. The only difference, and that isn't any different either really, is this selector piece. So this is going to say anything that matches a label, app Rails, and we'll talk about labels in a minute, that's part of my deployment now. Make sense? And what's this do? How many containers will run with this? 8 containers. Cool. Everyone get why that's the case? Okay. So same deal. So now we have 4 pods on a 3-node cluster. We get IP addresses. Okay, what's wrong with this? How do we talk to these things? Services. This is another abstraction in Kubernetes. And you need to have services to make this whole thing work, right? Because you can't just start guessing where pods are. There could be 50 one day on one node, and then there could be none on that node the next day. So a service is an abstraction layer. It's a VIP, right? It's a virtual IP address. And it's going to do this. It's going to make it so I don't care about the rest of the IP addresses of the pod. And now I have this one stable unit to talk to. I I have multiple services, and I can put it behind a load balancer. So I can put DNS in front of it. I can do whatever I want, right? This is what a service looks like. All it does is we define some ports and then a target port. And then the important part really here is this selector app Rails, right? This is going to say anything with the label of app Rails, which was our deployment that we just saw, that's now part of my service. So we have a container. We have 2 containers in 4 pods in 1 deployment in 1 service. So that's kind of, sorry about that. Okay. Anybody know what this does? Extra super top secret bonus question. What? Yeah, Kubernetes master. Correct. So thank you. Everyone gets this wrong because you wouldn't expect this, right, if you didn't know what was going on. But this is actually going to use what's called the cloud controller, cloud something controller. I have it on a slide. But it's going to spin up a load balancer on behalf of the cluster, right? It's going to go out to GKE or AWS and say, give me an ELB type thing, and I can start routing traffic to. What's wrong with this from a security perspective? Do we want random people spinning up external IP addresses in our cluster? Well, I guess we all don't care. So ideally, we do not just allow that to happen, right? Because first, it's expensive, and second, you're exposing things to the internet through YAML that you don't know about. That's that whole asset problem, right? You just added an external facing web app, microservice, whatever, and it's just 1 line of YAML. Not great. Labels and selectors. Metadata. This is very simply just a key value pair. You define the key, you define the value. It looks like this. This label is app Rails. It doesn't have to be app, and it certainly doesn't have to be Rails. Probably won't be Rails. Selectors. This is how we put things into a deployment. This is how we start taking pods and making them part of a group, right? So loose coupling. We talked about this in infrastructure as code. So anything that matches the label of app Rails, that's our selector. Pretty simple. We can do things like this, right? This is all the same app, but we have different labels that we can slice and dice and route traffic to differently. And this is really powerful stuff. And I recommend figuring out your labeling schema early on and document it and make sure that you don't get yourself in a bind. I've watched that happen. Ingress. So instead of an external load balancer, we can use what's called an ingress. An ingress operates at layer 7, so we get to see HTTP traffic. What's this look like? What's this do? So instead of having an ELB, now we have an Nginx type of proxy that can actually look at subdomains. We can look at URL paths. This starts to look like an Nginx vhost, like classic vhost style config, right? This is where we're going in Kubernetes, and people are using this more than load balancers now. Same problem exists. We could still expose things to the world, but we have more power to route traffic intelligently. Namespace, this manages different environments. This is not a security construct. This is just to make sure we're not stepping on each other's toes in the cluster. So I can have n number of namespaces, development, QA. We wouldn't want to have prod and QA in the same cluster, right? Why? Even if they're in different namespaces. Where's my Kubernetes guru? Why would we not want production and dev in the same cluster, even if they're namespaced out? And the container escape, web app vault, there's all sorts of issues with that, right? Keep prod in its own cluster. That's all I'll say about that. Okay. What time is it? We're gonna not do all these. So I do want to kind of show the isolation model, and then we're going to step through. Do we want to understand what's running on the master, what's running on each node, or do we want to just like copy and paste commands into our terminal and just run to see what happens? YOLO. Do you want to learn a little bit about the internals and like really quick? Okay. Okay, let's do it. I think it's an important piece. We'll just rock it, huh? Okay, cluster. Let's talk about the master. Master has a few really important pieces running on it to make this whole thing happen, right? We have the API server, scheduler, controller manager, etcd. Number one, the API server. This is how we talk to our cluster from the outside world. So who knows what kube control command is? kubectl. Have we seen that? Kind of like just the CLI interface for talking to clusters. That's talking directly to the master on using the API server. Everything in Kubernetes is an API object. Even internal components talk to the API server to make everything happen. It's very, very chatty. But that's just how Kubernetes is. You have to talk to the API server from the outside, and the components have to talk to it from the inside. Scheduler. This is going to pick a node to schedule a pod onto, right? It's going to say, does the node have the resources? Is the node up? Is it healthy? Is it alive? Am I allowed to use it based off of node affinity, et cetera, et cetera. Controller manager. There's lots of different controllers built into Kubernetes on the master itself. And I'll blow this out in a minute. So we have the kube controller manager, which has node controller, replication controller, service account controller. So node controller is able to go out and schedule pods on a node. Replication controller, this is a really important one. This is going to actually supervise the number of pods that are running on any given number of nodes and make sure that they match with the desired state. This is that thing everybody's talking about, like, I want 15, make sure there's 15. And the replication controller is going to be constantly talking out to the nodes to say, are you up, are you up, are you up? If it goes down, it's going to go talk to the scheduler and put a different pod on there. We have a notion of service accounts in Kubernetes. What's a service account? What? Go ahead. Non-human ID, right? So Kubernetes comes with lots of service accounts out of the box. This has been a big point of security contention over the past couple years because they used to come with service accounts that got auto-mounted into containers into certain directories that had root-like access. We'll talk about that hopefully in a minute, but that's bad, right? So now with role-based access control and things, we don't see that sort of blatant misconfiguration. We have the cloud controller manager. So this is cool. So we have the ability to spin up VMs in our cluster, build routes, services, and volumes like EFS or NFS volumes out in your cloud provider. What does this imply that Kubernetes has access to? Everything, right? Yeah, that's messed up. So we basically, by default, put a token of sorts in our cluster that gives Kubernetes the ability to spin up VMs, gives Kubernetes the ability to spin up load balancers, all this stuff. So it seems like magic, right? You just like click a few buttons and you have the thing running and it's awesome and life is good. But if you're security practitioners and you're trying to roll this stuff out, know that that's part of your threat model now. Somebody compromises your cluster, they can do lots and lots of different bad things throughout your entire cloud environment. Okay, replication controller, that's too simple. etcd, what's etcd? Come on, somebody knows what that is. Distributed key value store, simple, right? Well, it's not simple to manage, but it's simple in theory. And Kubernetes uses etcd as the backend storage mechanism, right? So when I submit YAML to the master and say, I want 15 of these nodes, it's going to tell etcd that's the desired state. It's going to be stored as a key value pair in etcd. And Kubernetes is always going to update etcd for you. What else is stored in etcd? Kubernetes guru, David. What else do we store in etcd that freaks me out? Secrets. Yeah. What are secrets? Database password, whatever. That's stored in here. What's bad about that? Let's keep diving into this. I have a whole section on it, but we'll just cover it now. etcd's not encrypted at rest. And if you have a cluster of etcd workers, the way they communicate to one another by default is not over an HTTPS or TLS encrypted connection. So we just went back to like 1995 for storage of secrets if we use this as is out of the box. Now this is changing. This is an area to watch. We have encryption at rest now, but it's in alpha. You have to go to your API server, put some crazy flags in, and tell Kubernetes you want to do it. It's not a default. So just know that if your developers come to you and say, we just want to use this because it's there and it's built in, you're going to have to do a little bit of work and threat modeling around that now. Nodes. Nodes are a little more simple. We have kubeproxy, which handles, basically all it does is manages IP tables rules. This is not a true proxy. It used to be, but it's not really anymore. So the networking in Kubernetes, which we're not going to go into right now, there's a video from Tim Hawken, Google Next 17. It's the ins and outs of Kubernetes networking and GKE. He goes into like crazy detail about the actual like networking internals of Kubernetes, way more than we're going to tonight. Just know kubeproxy handles IP tables. Kubelet is how we talk from the master to a node. So kubelet is an API in and of itself. Kubelet runs as that communication piece from the master to the node. This is bad. It can be bad, right? If we leave kubelet open to the internet without authentication, what happens? What can we do? Yeah, you can mine Bitcoin, but how? Yeah, because it's an API. So even in the docs, this is like in big bold letters. It's like, don't put your nodes in, don't not put TLS on them, and don't put them on untrusted networks. So this is kind of on you depending on how you spun up your cluster. GKE obviously isn't prone to this, but not everybody uses GKE. Some people spin up their own clusters with their own components using Terraform. So always have certificate-based authentication so the kubelet and the master are mutually authenticated to talk over a TLS connection. Or you will have Bitcoin miners on your Kubernetes cluster. Which is the best Bitcoin miner, right? It's self-healing, it's auto-scaling. You can run high GPUs, it's the best, man. So the node also has a container runtime. This is just Docker, simple. Isolation model, this is GKE, GCP specific a bit, but project. So think of this as your AWS account if you're using AWS. Cluster, node, pod, and then containers in the pod. And each are different layers of isolation. This is like an onion, right? Namespaces offer little to no security benefit, but they are some level of abstraction. They do provide a little bit of isolation there. Okay, 11 steps in 2 minutes. Okay, DevOps, or lifecycle of a pod in 11 steps. DevOps bro. Schedule Rails YAML file. We looked at that before using kubectl. We do a kubectl create -f. Kubectl talks to the API server. It's running on port 8443. We're authenticated. We're allowed to do this. API server says, hey, etcd, we need n number of pods running of this particular image. etcd stores that as a key value in the database and says, okay, API server, you're good to go. I stored it. Let's schedule this thing. API server talks to the scheduler. Scheduler then decides which node is healthy, which node is available, where we can start running these particular pods. Then API server will talk to the kubelet, hopefully over mutual authentication and over a TLS connection. And the kubelet then tells the container runtime, the CRI, or AKA Docker, to go do some work. So the kubelet invokes Docker. Docker either pulls the image from the node, it could already be there, or it goes out to your container or your image registry, Docker Hub, or on Google Cloud, pulls it in, the container starts running within the pod, and the kubelet says, hey, it's up, we're healthy, we're good. Informs the API server. API server says, okay, etcd, you can now update the actual state to match the desired state. We're stable. Then the replication controller kicks in and supervises the process. It's going to say, do we have 3? Do we have 3? Do we have 3? And if one goes down, the whole process starts over again. Okay. We're going to do this lab. Did everyone finish lab 1? We logged in. We're DevOpsing. I expect to see this on everybody's LinkedIn right after class. Kubernetes administrator. So the cluster setup is very simple. This implies you did your git clone, right? And we're going to start running some of these kube control commands. That's what we're on, right? We're on 3. Yeah. What do all caps mean usually? Just read it and don't just paste blindly, please. I'll tell you how many times I've had to change that one. So we'll go we're going to go 5 minutes and then I'm going to talk some more so everyone can keep working and listening at the same time. But this should help us see how this whole process starts to kind of pan out. I got some robot coffee today on the walk over. Have you seen that here yet? I thought it was pretty cool. It was, yeah. In the slides? Oh, yeah, sure. Okay. I'll take a note of it. Thank you. I only have 390 of them to keep track of. So you wouldn't normally, this isn't how you would manage Kubernetes objects in production. This is just to ease our way into using manifest files, right? That's a direct command that is really great for testing purposes and debugging, but it doesn't, you lose all of that infrastructure as code that we just talked about. Anybody have any questions about what the architecture overview? Oh, this looks dangerous. is not enough.
Yeah.
You can't get through them and actually understand what's going on. But
Yeah, like the first lab or the whatever the second lab we did.
Thank you so much for coming tonight. Oh, I can speak loudly.